My name is Zach Bohl, and this is my final presentation for CIV110 in the spring of 2019. I've had some technical difficulties, so please bear with me. The topic of this presentation is Roman civil engineering and how it influenced modern civil engineering. Let's start with the root word of engineer, which is engine. Engine is derived from the Latin ingenium, which is defined as the innate quality, trick, or clever device. Obsolete definition of engine referred to a military machine used in war, like a catapult. The original engineer was one who operates a machine. The U.S. Army Corps of Engineers is a modern representation of the role of civil engineering in the Roman world. They bridge the role of traditional military and modern civil engineering. They are charged with the construction, maintenance, and repair of canals, locks, and levees. Also, beach nourishment, environmental regulation, and ecosystem restoration. Aqueducts were not a Roman invention, but they built them on a scale never seen before that point in history. The Aqua Appia was built in 312 BCE. It was the first large aqueduct built in the Italian peninsula. Roman aqueducts had no pumps to propel their water to the cities, only gravity. Modern standards for the flow of water are at a minimum 2%, or approximately a quarter inch per foot. Imagine the precision it would take to hold those standards for a distance of over 50 miles without modern technology or even the technologies of glass optics that existed a few centuries ago. When you think of an aqueduct, you probably think of a large arch structure, but much of the distance span was actually underground. This underground network was not dissimilar to the concept of modern water mains, without the pipes, of course. They only achieved this feat because of the invention of waterproof cement. Prior to this, any masonry structure would have leaked, proving inefficient. Imagine, if you will, an entire city surviving on common wells and fetching water with a bucket. The sanitary conditions that must have existed in a city with a population that numbered in the hundreds of thousands would have been, by modern standards, abhorrent. Now imagine clean running water. Distribution of this water was made possible with clay tile and lead distribution pipes. Clay tile was still used until very recently, until the invention of modern plastics. We still use this technology up to less than 100 years ago. The use of lead was only made illegal in this country in the 1980s. A little plumbing trivia fact is the word plumber comes from the Latin plumbum, the word lead. Evidence of this can be seen on the periodic table. Pb is the symbol for lead. Now imagine sewers that carry the water away from the cities that are just as important. Sewer systems do not get the admiration of the aqueducts, but were just, if not more important. Without the ability to remove what we now call wastewater through a sanitary sewer, conditions, even with fresh water, would have been terrible. Underground labyrinths of pipes and arched tunnels carried the wastewater away from the cities to the rivers. This practice was still common in the U.S. until the turn of the 20th century, when treatment plants began to be constructed. In the modern world, people still use these ancient methods and technologies until recently. The principles applied in antiquity still applied now. Roman roads were designed with an elevated crown in the middle and gutters to collect runoff. This design is still utilized in modern building techniques. The lack of modern topographical maps to plot a course, or even the invention of the compass, did not hinder the Romans. So to keep the road straight, a tool called a groma was used. The groma was two pieces of wood nailed together to form a cross with right angles in all four corners. Each piece had a lead weight on the end. When the operator looked down the groma and aligned the lead weight to ensure a straight line, they then planted wooden stakes in the ground along this trajectory to ensure a straight road. This rudimentary tool was capable of laying out roads that are known to this day as being straight. The fact that some of the roads still exist today is a testament to the engineering marvel that was the Roman road system. What modern engineering project will still exist in 2,000 years? A two-lane paved road with a gravel stone base and drainage on either side is something people are still constructing to this day. The Romans built the roads primarily for military transport and to enable the free flow of commerce. Commercial trading and the taxes levied on that trading paid for the roads and other civil engineering projects in the Roman world. The same as today. The military mobility was the key to Roman success. When a threat or uprising sprung up in the Republic or Empire, quick action was needed to put a swift end to that problem. The modern-day Autobahn and Eisenhower interstate system are both based on this concept. Route 13 is called Military Highway. That is local proof that this concept is still alive and well. An elevated crown with gutters on both sides is the primary design of city streets today. As previously stated, this design dates back to antiquity. It is still utilized because it works. The simple concept of pitching water off of a roadway to maintain structural integrity is the most basic concept in road construction. Gutter systems collect water and expel it to a low point away from the road. In modern construction, waterproof concrete, another Roman invention, enables structures such as drop inlets and catch basins to remove standing water from the roadway. It is conceptually the same as Roman times, even if in practice it is more complicated. The base of the road is the most important part. The foundation of something is its strength. Without a stable base, any structure, whether a road or building, will eventually deteriorate. The longevity of the Roman roads is evidence of the engineering capabilities of the Romans. 2,000 years after construction, some roads are still operable without regular maintenance.